Hello there, this is a geometry video. It is chapter 11, section 3, and today's topic is areas of circles and sectors. Now a sector we'll talk about a little bit later, but just so that you know, a sector is basically a portion of a circle. So here we have the area of a circle. It's going to be a short lesson because I'm pretty confident that most of you already know that the area of a circle is pi r squared. So again, r is the radius of the circle. And pi is approximately 3.14, but we don't want to use 3.14. We actually want to use the pi button on your calculator when calculating when it asks you to round. If it doesn't ask you to round, then we want you to leave the pi in place. And I will demonstrate for you as we go through the examples. So in example 1, it says, what is the area of the circular putting green shown to the nearest square foot? Now it doesn't look very circular. But that's because you're looking at it from a far off distance or whatnot, but this is supposed to be a circle, so we're going to base it off of that. And so what we know is that the diameter of the circle is 20 feet, and the diameter of a circle is equal to 2 radiuses. So the diameter is 20. It means that the radius is 20 divided by 2, or 10. Once we know what the radius is, all we have to do is plug it into our formula for area, pi r squared. So we know that 10 squared is 100. So the actual area is 100 pi. And we have square feet. But it says to the nearest square foot, which means that they want us to actually round this off. So this is the exact answer, but we're going to go 100 and then times it by pi, so second, and then the caret key, and the caret key looks like this. It's right below the clear button. So we go 100 times pi, and we get 314.159. But it says to round to the nearest square foot. So because it's 314.1, we're going to round it down to just 314 square feet of area for this putting green. All right, so that is how you use the formula for area. So we're going to let you do this guy. And then we're going to go to example 2. And it says, find the radius of a circle with an area of 95 square centimeters. You don't actually have to have a circle to be looking at to do this problem, but we know that the area is equal to pi r squared. And in the problem, they tell us that the area is 95 square centimeters. So we're going to replace the a with 95 pi r squared. And what they want us to do is find the radius. So we want to find what r is. So we're going to divide by pi on both sides to get rid of the pi. And then that's going to cancel. You're going to get r squared equals 95 over pi. And then we want to square root so we can get rid of the square. And then r is going to be approximately the square root of 95 divided by pi. So on your calculator you want to go and do the square root button. And then you want to put 95 divided by the pi button, and then close your parentheses. It's very important that you do that. And then you're going to get 5.4999. It's 0.49903 and on and on and on. But it says find the radius of a circle with an area of 95 square centimeters. So it doesn't tell us how they want us to round it, but we're going to go ahead and round it to the nearest tenth, which will be 5.5 because of the 4.999, so 0.5 centimeters. So there we go. Now you can try do it yourself number 2 right here in the bottom of the screen. And then we're going to go to the area of a sector. Now the area of a sector, I was saying earlier, the area of the entire circle is pi r squared. So this formula should actually make sense because all you see basically is that the ratio of the area of a sector, so if you were to take the area of the sector, which is the piece that I've highlighted, and compare that to the area of the whole circle, which we know is pi r squared, it would be the same as the ratio of the degree measure of the intercepted arc and 360. So the degree measure of the intercepted arc. So basically, when you have this sector, it's intercepting or intersecting the circle in these two spots. So this is what we call the arc right here. This is what they're referring to when they say intercepted arc. So the degree of this arc is what the x value is, so we put that there. And then the actual degree of the entire circle, if you had the degree of the arc for the entire circle, it would be 360 because there's 360 degrees in a circle. So you end up with this. We know that the areas of the sector compared to the whole and the degree of the sector compared to the whole are equal. And so if you just do a cross multiplication, you will get that 360a equals x pi r squared. Like so. X times pi r squared, divide by 360, and voila, you have the formula there. Now, it's not entirely detrimental to you if you don't fully understand that. You can ask me in class to further clarify. Another way of looking at it, which I find a lot easier to look at it, is that this fraction right here in front of the pi r squared basically just tells you what part of the whole you want. For example, we already know that the area of the entire circle is pi r squared. What if I only wanted half the circle? Well, half the circle would be an arc. You know, it would be all over here, it would be half the circle, and this would be 180 degrees. So you would put 180 over 360, which is 1/2, and it would tell you half times pi r squared. It would be half the circle. If you only wanted a quarter of the circle, then this would be 90 degrees, and it would be 90 over 360, which is 1/4, and it would be 1/4 of the circle. And that's an easier way of looking at it. So either way you slice it, no pun intended, you're going to get that same formula. So here we're going to apply it in this example. Here's our last example, very short lesson today. A circular pizza has a diameter of 12 inches and is cut into 8 congruent slices. What is the area of one slice to the nearest 100? So, you need to have a picture, but I'm going to go ahead and get a picture going for you here. So here is our pizza. And basically what they're telling us is that this pizza is being cut into 8 congruent slices. So 1, 2, that's 4. 5, 6, 7, 8. So now you have 8, hopefully, congruent slices. I try to get them to look as congruent as possible. And then they want you to figure out what the area of only one of those sectors is, or one of those slices. So basically you're looking for a sector here. We also know that the diameter is 12 inches, which we said earlier, the diameter is 2 radiuses together. So the radius in this case would equal 6. So we have a radius of 6, and we have 8 slices. So because there's 8 congruent slices, we're going to take the 360 and divide it by 8, because that'll tell us what the degree measure is for each of those sectors. So if you take 360 and divide it by 8, you get 45. So the degree here is 45. Now all we have to do is plug it into our formula. Our formula says that the area is going to be equal to the degree of 45 over 360 times pi r squared. Now 45 over 360 is, guess what? 1/8. So you didn't even have to figure out, that this was 45. I just did that so you could see how you can plug it into the formula. But basically, because I only want 1/8 of the circle because they're 8 congruent slices. I only want 1/8 of it. All I had to do was put the 1/8 in front times pi r squared, so 6 squared is 36. All right, so just so that you know, that's all that front or that fraction in front of the pi r squared is telling you. So 36 divided by 8 is 9/2. So I'm taking 36 divided by 8 is 9/2. So the answer is 9/2 pi, but it does tell us to round to the nearest hundredth. So we're going to take 9/2 in parentheses, 9/2, times it by the pi, and that gives me 14.1371. And because it wants the nearest hundredth, we're going to get 14.14 because it's 137. So we want 1/4 square inches for this slice of yummy, delicious pizza. All right, so that is how you use the formula for the area of a sector. So now we want you to do this do-it-yourself question and find the area of the shaded sector. Make sure that you round your answers to the nearest tenth. Want to be careful with part C that the easiest thing to do here is to subtract 65 from the 360 so that the area of your sector over here is what you want. You don't want the 65, you want the whole over here. You can also subtract the small white portion from the area of the whole also. So a couple different ways for you to do that. But once you have completed this example, you will have completed your notes for this lesson. And I will see you in class, and thanks for watching.